As Dawn said, I came up with this talk at the last minute. I'm not quite sure what it says about me that I wasn't really interested in talking when I had weeks to prepare, but when Dawn said, can you do it in like a few hours? I said, yeah, it sounds like fun. Dev to delivery with Puppet, Vagrant, and AWS. That's my company name. I wasn't very inventive. So who am I? Why am I standing here? Because the other guy pulled out. We covered that. So I've been using Linux for a long time, using Puppet for quite a while as well. I run a company in the north. It's no bother categorizing it more than that because you won't understand in London anyway. We do outsourced ops for other companies. So basically, people give us their infrastructure and we make sure that it works and they're happy. And if it doesn't work, then everyone's unhappy. So here are the tools we're going to be using today. Hopefully no one's surprised by the fact Puppet's there. Also Vagrant, raise your hand if you've used Vagrant at least vaguely. Okay, that's a lot of people. Good. Amazon Web Services as well. Actually, I would say that every single component in this talk you could replace with something else, and hopefully, if I've done it right, the talk would still be useful. So you could use Chef, or you could use some other mechanism for deploying code, and you don't have to deploy to AWS, and it would still be useful if I've done this right. Maybe it'll be useless, but I'm talking about these because this is what we use, so this is what I know about. So what's the point of this talk? The point of this talk is to avoid this situation. Work fine in dev, it's an ops problem now. Raise your hand if you've had some variation of this. Yeah, so that's most people. The people who didn't raise their hands, are you guys all developers? Yeah? Yeah, okay, right. So what we have is we have a lot of different environments. So we have dev, that might be a local dev environment that lives on a developer's machine. We might have an integration environment. We might have a QA environment. We might have a stage. You definitely have a live environment, I hope. What's particularly fun for us, because we support multiple companies, is that lots of people use these same names for different bits of infrastructure. So for some people, they'll call stage UAT, and for other people, integration testing is UAT, and even within the same company, people get very confused about these names. We just are permanently confused, it's fine. So which parts of your environment are actually managed by Puppet? So for a lot of people, it's just stage and live. And that is part of the reason why we have this work fine in dev's ops problem now. The other reason is because your developers are arseholes if they're saying that, but sorry, we can't fix that. We can at least give them the tools that make it so that they can see the problem in their dev environment. So hopefully they'll fix it. So what we want is we want confidence that things will work correctly in production, because I don't want to get woken up at 3 in the morning by a problem that actually should have been found in development, but wasn't because our environments were inconsistent. So we want consistency between environments. We want consistency between all environments. So that means even the developer's local virtual machine, where they just play around with stuff, we want that to be consistent as much as possible with the production infrastructure. Clearly, you can't have a complete copy of the entire production infrastructure running on every developer's laptop, but we want to get as close to that as we possibly can. So, in order to make this work, what we need to do is we need our ops team, we need our dev team to cooperate. Because, some of you maybe still live in this throw it over the wall type situation where the devs, they'll build something, then someone comes to you as an ops guy and says, right, so we've built this thing, we need some servers that look like this, and then we'll be able to do what we need. That's a bad way to be. It causes lots of IT problems. So I've come up with a name for this ops and dev cooperation. It's called ops development. So I think this thing's going to be big. I'm thinking maybe some conferences, ops development days maybe. Maybe people will start calling themselves ops development engineers or ops developers, I don't know. It should be good. So in all seriousness, I've deliberately not used DevOps because lots of people are using the word DevOps now and they clearly don't understand what DevOps actually is. I won't name names because it's on camera and we have quite strong libel laws in this country. But yeah. So you need, I would say, to do this well, ops to be involved in the development planning process. So before, or pretty much before any serious code's been written, you need the ops team to be involved. That doesn't mean you can't retrofit it, it just means it's a lot more work to retrofit this. So as your dev guys are saying, oh, maybe we'll use this thing, maybe we'll use this other thing, you should be selecting Puppet modules. There might be modules off the forge, or there might be modules that you're actually writing, and writing the manifests as part of the development process. And if you do it that way, it doesn't mean everything's going to work perfectly, but at least you've got a much better base to start looking at the problems from when they do occur. So, you develop on environments that are provisioned by Puppets, by Puppet. So, as early as possible, you want your devs to be writing and deploying their code onto systems that Puppet is configuring, rather than them having a local dev environment that they've manually configured and then having a load of staging and live environments that are configured by Puppet. So how do we do that? A few different ways, but the way which we've chosen is Vagrant. So most people raise their hands. Vagrant's basically a really cool tool for bringing up virtual machines. You can bring up a dev instance really quickly. You can run it on your local machine. The nice thing about Vagrant is it's really quick to get something working. So you can be developing your Puppet modules using the same Vagrant environment as the developers are using. So you've got a nice synergy there. And it avoids ops being a block of a dev. Because the worst thing from a developer's point of view you can do is, okay, so I need these things, and ops go away and say, well, it's going to take us 3 weeks, I'm afraid. Because, well, I need to get writing some code. And so inevitably, they're then going to build their development environment by themselves, and then you don't get this. So you need to get something up and running as quickly as possible, and Vagrant is a great way to do that. So basic workflow we have is that when something is really only affecting one developer, so one developer is working on a feature branch, that development happens on Vagrant VMs. But when you're deploying something that is shared, so maybe a staging machine or a QA, something like that, that happens via Jenkins, because Vagrant is great at giving an individual feedback on what's happening, but Jenkins is much better at allowing the whole team to see, okay, this guy just pushed this new code and all the tests ran and they all failed, or they all passed. So if you're going to do this right, there should be only one set of Puppet manifests and modules. What I mean by that is there is one repo. Actually, it may even be the same repo as your code lives in. We don't actually do that anywhere, but I can see that could work. And so it gets tested and deployed in the exact same way as the code. So you start out in your local dev environment running Vagrant, and then you push it up to the staging infrastructure or whatever steps you've got along the way, and then it gets deployed to live. So basically, when you start with your code, that should eventually get merged to live. So everything's running off the same code base, it's just not necessarily running off the same version of that code base. But clearly, the environments are different. You don't use the live database, I hope, on your staging environment. And there are going to be other differences. So your Vagrant machines probably don't have as much RAM as your real live machines. So you need to have different settings to cater for those different resources. So how do we do that? Well, one solution is Hira. Hira is a really nice tool. Before Hira existed, we used to have lots of, if the environment is this, then we do that. And if it's this other thing, then we do that. Hira removes a lot of that ugliness. So basically, we have different environments, as in Puppet environments, and we put the things that are specific to an environment in our Hira YAML file that's related specifically to that environment. You could, if you wanted, if you're worried about giving away sensitive data, maybe you've got database access credentials that you don't want your developers to have for some reason. There's a tool called hira GPG that allows you to use symmetric encryption on your data. So hira YAML. So basically all we're saying is, look in a file that's the same name as the environment is. So it might be staging, might be Vagrant, might be live. And then if it's not in there, look in the common file. So that's a basic hira YAML. And then in Vagrant, we just specify, okay, yeah, here's the name of our environment. So here we're saying, right, this environment is called local dev. So it uses the YAML settings from Hira that it's pulled out the local dev .yaml file, where there are differences specific to that, and it will fall back to common.yaml if they're not found in there. So the basic workflow for a developer, at the start of the day, your dev runs Vagrant up, and they get the latest copy of their environment. So they probably did a git pull or whatever before that, but you're building the entire infrastructure a lot. And that's great, because that means your Puppet manifests are getting tested at the same time as people are running code. So if there's a problem with your Puppet manifests, hopefully that's going to get picked up by your developers way before it gets anywhere near production. So we run Vagrant up. We get a copy of the environment. Your developers develop on their local machine and then save either the code, so if it's a scripting language like Ruby or Python or whatever, the code sits in a shared Vagrant directory. If they're Java devs, then you might output ears or whatever onto this shared volume. And at the end of the day, they just destroy that environment. So the next day, you're getting a brand new environment, and you can be confident that this environment is really going to work properly when we make it to production. So, some tips on using Vagrant. Avoid VirtualBox wherever you possibly can, because it just crashes machines. If you're running Linux, then there's a very nice thing called Vagrant LXC, which uses the container infrastructure within Linux. If you're using that fruit-based Unix, VMware Fusion, if you're running Windows, you've probably got bigger problems than VirtualBox. So, what you can also do, this is where we start with the Amazon stuff. So Vagrant can also bring up machines in AWS as well, which is great. So you can run some stuff on your local machine. Okay, that looks fine. I want to show it to some other people before we start merging it in. You can do Vagrant up, -- provider equals AWS, and it will spin up the exact same environment, but within AWS. So that's great. VirtualBox doesn't crash your laptop. Clearly, there are cost implications to this. Maybe you want to do all your development testing in AWS. It depends how the guy holding the purse strings feels about that. So, once we get to our main environments, I would say these would live in AWS, and they would be provisioned by Jenkins. So we merge it into an appropriate branch, and then we let Jenkins take over. It may be that you have integration tests running from feature branches as well. Well done you, if that's the case. There are some key advantages to using AWS, which I suppose are equally true about other cloud platforms, but I don't use those, so I don't really know about them. We don't actually need to run our test environments all the time. We can have the environments we want only when we need them, and they can be powered off the rest of the time, which is great. There's one really important point if you're going to do this. Don't tell the guy who's in charge of the budget you're going to do this until later on. And what I mean by that is we want to use some of the money we've saved by having the test environments turned off a lot of the time to build better test environments. Specifically, we want to have some high availability in those test environments. I can think of several occasions where things have worked absolutely perfectly in staging, and it gets deployed to live, and oh no, no, that's not working at all. And the reason is because in staging, there's one web server, one database server, maybe one Redis server or Memcache or whatever, and in live we have lots of them. So you're not really testing like with like. So we want to have as early on as possible in this setup, we want redundancy like we have on live, so that we're testing like with like as much as possible. And we want that as early on as possible. So if you've got a QA environment and then it goes to stage and then it goes to live, you probably want that on QA as well as on staging, because you want to catch these problems as early on as you can. So this is what happens, remember, if you don't do it that way. So there's a basic Jenkins workflow. Someone commits to Git, an environment gets provisioned by Jenkins, some automated tests hopefully get run, maybe some manual tests as well, and then we destroy it again. There's a problem with doing it that way. Some resources take quite a while to provision. So it's all very well saying, we just spin up a whole copy of our infrastructure. But if spinning up a whole copy of our infrastructure takes an hour, that might not be suitable when you've got an environment where people are merging code, trying to merge code at once every 20 minutes or so. So some resources are slow to provision. We could just say, you know what, we'll just run the staging infrastructure 24/7, it's fine. There is another approach which is like a hybrid between that we use a lot, pilot-like provisioning. So basically, here's our setup. We have our load balancer sitting there, our cache tier, which is empty, our web tier, which is empty, and then we have the database sitting there ready. That database is running 24/7. And then when we get a new merge, Jenkins just fires this up. So in Amazon language, this is a set of auto-scaling groups. So we have an auto-scaling group for the cache tier, auto-scaling group for the web tier. We just have maximum or a desired capacity set at 0 when it's off like this, and we change the desired capacity at the point at which we actually want to test things on this infrastructure. So we're saving money by not having all these servers running all the time, but we're still being nice and quick to be able to deploy these things and test them. So yeah, there we are. That's how we're doing that. You might want to make sure that you have a mechanism for turning those machines off again at the end of the day, because that's a really easy thing to forget. And Amazon still charge you even if you weren't really using it. So basic conclusions. Your infrastructure development should run in parallel to software dev. That doesn't mean that you necessarily have your software devs writing your Puppet manifests. It just means that you should be, the ops guys should be part of the same team, and you're doing the whole DevOps thing as it was originally intended, and minimize all the differences from production as much as possible. Because if a dev can't see the problem in their environment, it's just going to continue being there, and you're going to get woken up by it, and everyone gets annoyed. So there we are. Questions? Anyone? Yeah, this guy.
I saw you keep a staging database or a test database. Remember, how do you handle cache content when you're spinning out environments?
So the simple answer is, the question was, we have a staging database that's kept there, but how do we deal with cache freshness? So basically the answer is we typically don't. We could, things like Redis, for example, we could, Amazon allows us to snapshot our Redis data store, and we can build a new Redis instance from a snapshot. It's not something we've worried about previously. If there's a use case that needs that, then that's probably what we'd look to do. Yeah.
How do you encourage perhaps your developers to rebuild their individual run Puppet every day?
Okay, how do we encourage our developers to rebuild? So this is particularly hard for us because we're essentially a third-party company. So the way it works typically is we will have a customer. Our customer will engage with us and with a third-party development company. So these people are working for a different company, and their customer is our customer as well, but there's no relationship with them other than that. So I would say that most developers actually are pretty amenable to the idea of doing that when they realize that actually this makes my life a lot easier because things work. Clearly, that does also mean that they have to type Vagrant up and they have to wait for the VMs to boot. If you're using something like Vagrant LXC, that really cuts down the amount of time to provision the environment. But yeah, there's an issue there. Pretty much, I suppose you have to hope for the best at some level. Any other questions? No, that guy's just stretching. Yeah. Okay, cool. Right, thanks everyone.